everybody. As you might see, I am not Elisabete Gomes. I am presenting on behalf of Elisabete, who has not been able to be here. She have been retained in Portugal. I'm João Nisa Ribeiro here. And this is part of PhD program in which we talk about and which we analyze information on MAP. I would like also to thank to the scientific committee of having accepted this presentation. Arigato. Well, we all know that paratuberculosis is a very important cattle disease. It's important either in beef and in dairy, and it's increasing worldwide. Several reports which studies the prevalence, they acknowledge that in most of the countries paratuberculosis is increasing. Even though we know that it poses and places economical problems because of losses, because of premature culling, because of losses in the slaughtered cattle with clinical diseases, dairy reduction in production, reproductive deficiencies. So it poses direct and indirect losses. The clinical cases, they also suffer for animal and welfare issues. And plus, more and more, it becomes associated with some human health diseases, for instance, like Crohn. So even it is not proven, it might be a problem in future years, in years to come. Recently, EFSA has produced an opinion under the Animal Health Law, European Animal Health Law, which is producing a new list of diseases, and EFSA has produced an opinion under which paratuberculosis should be included in this list. And in future years to come, probably it will be deserve more attention in Europe. This question and the interest for this question in Portugal became and raised 10 years ago when I, with several colleagues in a laboratory which works for dairy farmers, prepared and put in place Bovicontrol, which is a program, voluntary control programs for BVD and IBR control. At that time, I decided to include paratuberculosis in the scheme. The program was well succeeded, and after we had enrolled a few hundred of farms and more than 5,000 cows in this program, and contacting with the vets and the farmers which had paratuberculosis on their farms, we noticed that the problem seems not to pose them problems, and they were not sensitive to the control of the disease. I have to say that this disease is not enforced disease in Portugal, so it was natural, but it was a question why people is not interested in controlling this disease. We know that it makes production losses. Why aren't they interested in this disease? So to understand what the losses were about and to provide us clues for better communication with the farmers, we start working on a database that became from this program, control program. We already published a paper assessing the first part of this information, and this paper concerns the impact of paratuberculosis in this data set of Portuguese dairy herds. And we have, let's say, summarizing our results, we have on this part the production losses, and on this part the impact on somatic cell. We can see the green line, it's the positive animals or positive farms, and these are the negative. So in these two slides, we can see the difference in production in positive farms or farms with positive animals and farms with negative animals, which is negative farms. And we see here the consolidated production per lactation of 5 consecutive lactations. In our data set, the more productive farms were the infected ones, even though in these farms they had higher somatic cell count. When we went to assess the cow's production over the lifetime, the 5 consecutive lactations lifetime, we were able to see that in the first 2 lactations, the difference in production is not that important. It becomes bigger as the lactation increases, and in fact it becomes significant. But even in the first lactation, we could say that an average seropositive cow performs better in terms of production than an average negative cow. Concerning the somatic cell count, they tend to increase, and seropositive cows, they tend to have higher somatic cell count than the seronegative cows. Then, knowing this, we decided to analyze a different aspect, which was the impact on reproductive issues. So we analyzed births to control, births to calving intervals, and then we analyzed the intercalving intervals, and finally the milk production, daily milk production per intercalving interval. Our data set contained 191 farms, 35,000 lactations from first to fifth lactation, and 30,000 first lactations. And from here, we calculated the birth to calving interval and the intercalving intervals. This data set is fairly representative of the Portuguese reality, which has nowadays we have 3,000 dairy farms in Portugal, in the continental part of Portugal, and this can be seen as a proxy of what happens in the dairy farms, in the dairy system in Portugal. So the cows were classified as positive, doubtful, or negative, according to the ELISA result. We considered positive all the lactations of the positive cow, and all the lactations of cows that had negative results were considered negative. The farms were classified as positive or negative according to the number of positives in the farm. Only farms with 2 or more positive cows were considered positive for the purpose of this analysis. So the outcome variables, as I told you, are the birth to calving interval, intercalving intervals, and the average daily production per intercalving interval. Factors we analyzed were the milk production per standard lactation, the linear of somatic cell count, and the positivity of the cows. The positivity of the farms were also assessed. We used linear mixed models to do this evaluation, and the measurement occasion is the number of days, the intercalving interval, and the production in that intercalving intervals. The model is a repeated measures model, so every cow has more than one observation. Small descriptive, we have this nearly 36,000 lactations. 4.7% of the lactations are negative. And according to the distribution on the farms, we have 64% of the lactations in positive farms and the remaining in negative farms. You can see the distribution of the lactations. This is the first lactation, about 13,000 animals, and fifth lactation nearby 2,000. The average production per lactation in Portugal is 9.5 thousand kilos, and the average somatic cell count on the data set was 150,000 somatic cell count. So we went to analyze the first outcome, which was births to first calving to see if seropositive cows were performing different than seronegative cows. We have here the distribution of the birth to calving intervals in negative and in positive cows, and the median time, it was 797 days for positive cows and 813 days for negative cows. So they performed a little bit worse. We have done a t-test, simple t-test, to assess if these were significant, and in fact you can see that there is a difference, an average difference of 14 days, which is highly significant for positive cows, which is that positive cows, they tend to calve earlier than seronegative. We then assess the difference between intercalving, between births to first calving in the farms, to see if negative farms performed better or worse than positive farms, and there was no significant difference. So, because we all know that the farm management affects the birth to calving interval, and in the regard to seropositivity, we saw that no effect is seen. We did not include this parameter in the final models because the parameter became non-significant when we do the backward analysis with a alpha of 0.1. We moved then to the next predictor, or the next effect, which would be the intercalving interval. And concerning the intercalving interval, we have then 4 intercalving intervals. 45% regarding between first and second lactation, 30% from second to third lactation, and so on. You can see that 4.8% of the intercalving intervals are seropositive, so the proportion remains. This is a box whisker of what we see in the different intercalvings, negative cows and positive cows. And we can see that it seems that there is no apparent differences in the intercalving intervals divided by seropositive. And from the model, we can see that the intercept is at 344 days, and lactation number tends to reduce this baseline value from 5 days, whereas the somatic cell count, they tend to increase as the intercept increases, which was expected. But the interesting thing is that seropositivity of the cow does not significantly affect this parameter. So seropositivity of cows seems not to play a role in these aspects. We move then to the third indicator, and this is an indicator which divides the total production, 305 production of the cow per the intercalving interval days. So it's average day milk production per intercalving. It has a fairly normal distribution, and you see that is 22 kilos per day. This parameter combines 2 variables which behave differently. We see that this is the variable, the milk production per intercalving day. It decreases as the intercalving day decreases. So for increases, I see this increases as the intercalving day decreases. Better daily productions, which was expected. But then it also increases when the global production per lactation increases, which is also expected. So this variable, which is the daily production per intercalving days, joins 2 variables which behave differently, but gave us a very interesting insight on the issue, because we have here the same picture of lactations, intercalving observations, And positive cows, they tend to increase the production slightly regarding the seronegative cows of the same intercalving. When we ran the model, we saw that the basic interception is at 22 kilos per day, as expected. The lactation number increases slightly that production. Somatic cell count are associated with a decrease, as expected. And the seropositive cow has a 0.4 significant increase in production per day, which if we multiply by the average 340 days, it's 300 liters or so.
I'll have to ask you to wrap up shortly.
It's finishing. So, to conclude, we saw that the burst to calving interval was not affected by seropositivity. The intercalving interval was not also affected, and this ratio, milk production by intercalving interval, was significantly affected. And we saw that in our data set, seropositive cows performed better, slightly better than seronegative ones. We will dig further on this data set. I have to thank SEGALab, which was the laboratory and provided us with the data on animal seropositivity, ANABLE, which is the organization, farmers' organization, which produce the information on lactations and somatic cell count, and the official veterinary authority, which gave us information about the animal movement and animal birth date. Thank you for your attention, and if there are questions.